Okay, this is the chapter 4 video problem. So the problem tells us that the farmer plans to grow orange trees, apple trees, pear trees, and lemon trees. So those are going to be all of our variables. So our x sub 1 is going to be our orange trees. X sub 2 is going to be pear. X sub 3 is going to be apple. And then X sub 4 is going to be lemon. So our first constraint is in regards to how many yards of land that needs to be dedicated to all of the fruit trees. So we know that the farmer has 640 square yards to plant trees on, and that says each orange tree needs at least 16 yards. So that's going to be our first constraint. So it's going to be 16x1 plus each pear tree needs 4, so it's 4x2, plus each apple tree needs 8, so 8x3, and then plus each lemon tree needs 12, so 12x4. And that all has to be less than or equal to 640. So that is our constraint for land. Our next constraint is in regards to how many working hours are available each year. So there are 900 total working hours available per year, and each orange tree requires 30 hours. So we have 30x1, plus each pear tree is 5, so that's 5x2. Each orange tree requires 10 hours per year, so that's 10x3, plus each lemon tree is 20x4, which is less than or equal to 900. So that is our working hours constraint. And then our last constraint is restrictions for irrigation. So they've been allocated 53,000 gallons of water per year. Each orange tree needs 500, so 500x1, plus each pear tree needs 800 gallons, so that's 800x2. Plus each apple tree is 260, so 260x3, and then the lemon tree needs 500 gallons. 500 gallons x4, which is less than or equal to 53,000. And that is our water constraint. Okay, and then our objective is to find the number of each tree, or find the number of each type of tree that should be planted to maximize profit. So we know that our objective function has to do with maximizing profit. So it says the profit per tree are 200, so that's 200x1 plus 100x2 plus 80x3 plus 120x4. So that's our z function. Now that we have that, we're going to plug all of this into our website. And our website tells us that the farmer needs to plant 10 orange trees, 48.36 pear trees, 35.82 apple trees, and 0 lemon trees. However, you cannot have a point of a tree, so we're going to round up. So that leaves us with the farmer needing to plant 10 orange trees, 48 pear trees, 36 apple trees, and 0 lemon trees in order to maximize profit at $9,701.49. But we're going to round that to 9,701. And then the problem asks us if there will be any slack in the system and what that means. So slack is basically like a fill-in for the inequality to make the inequality an equality. So for the first constraint, there is no slack. For the second constraint, there is no slack. And for the third constraint, there is a slack of 1.2 gallons of water that has been unused or is left over. In order to find slack, you plug in each of the answers you got for each type of tree into our constraints. So our first constraint for land is going to be S1, so slack 1. So that is a 16 times a 10, because they need 10 orange trees, plus a 4 times a 48.36 because that is our exact number of pear trees, plus an 8 times 35.82, which is our exact number of apple trees, plus a 12 times a 0 because we are planting 0 lemon trees. And that is 640, and that matches our constraint of less than or equal to 640. So that's no slack for constraint 1. For the second constraint, we're going to do 30 times 10 plus 5 times 48.36 plus a 10 times 35.82 plus a 12 times a 0, which gives us 900, and that matches our constraint of less than or equal to 900 hours. And then our last constraint is 500 times 10 plus 800 times 48.36 plus 260 times 35.82 plus 500 times 0. And that gives us our answer of 53,001.2. So what we're going to do is subtract that minus our constraint of 53,000 because that does not match, and that gives us a leftover of 1.2 gallons of water. So our S1 is 0, our S2 is 0, and our S3 for our third constraint is 1.2 gallons of water that have been unused or is left over. Thank you.